In this tutorial, we're going to try and understand how to authenticate a Node.js REST API using JSON Web Tokens. We're actually going to take a deep dive and understand all the concepts surrounding authentication. We're going to contrast authentication with authorization. We're going to understand how to store passwords locally in a database using something called hashing. Then we're going to introduce encryption, encoding, and signing and talk about how all of those are different from hashing. Finally, we have the knowledge required to understand how JSON Web Tokens really work. We're then going to implement an authentication middleware to protect our routes. Now, I know that sounds like a lot of concepts, but this is a highly practical tutorial. We're going to actually build out a REST API for authentication that you can use in any of your applications. We're going to explain concept by concept, and then we're going to focus on implementing them in our REST API. I hope you're excited for this one. Let's dive right in. In this section, we'll set up the Express REST API. I have an empty folder open in VS Code. I'm going to start installing dependencies. Let's first initialize npm. I use the -y flag because that means I don't have to type out each of these things. Let's go ahead and install the dependencies. So the dependencies we need are nodemon for running our development server. We're going to need Express, and we're going to need body parser, and then mongoose. Looks like our dependencies have installed. Now I'm just going to create a source folder to put all of our code into it. Our main file will be called server.js. Here I can require Express, like so. And then I'm going to create an application. We just have to invoke Express as a function. Now let's just test if our server is working. We'll give it a test route. Then you can get request response. And then for now we're just going to say response.send hello world. Now we make our app listen on any port you like. I'm going to use port 3000. And then I'm going to console log a message to ensure that our server is running successfully. Server running on port 3000. So we can save that. Before we run our server, however, we have to make sure that we have the dev script. Now I can run npm run dev, and that should start the server. Cool, our server is running on port 3000. I'm going to quickly test out that the API is working properly using Postman. Go to localhost :3000/ and then I get hello world. So our API is working correctly. Now before we type in any more code, let's understand how we want to structure our Express application. So let's talk about the structure of our Express application. We're going to be building a basic REST API for a to-dos application. So we have the client and the server. The client is going to send an HTTP request to the server. Let's zoom into the server and understand how the server handles this request. The server is going to be organized into several controllers. So there's the overall Express application, and then there are two controllers. We have the to-dos controller and the auth controller. The Express application is going to analyze the request, and then if it pertains to the to-dos controller, it's going to forward it there. And if it pertains to the auth controller, it'll forward it there. Besides our controllers, we also have models. We have the user model and we have the to-do model. So now that we understand how the application is structured, let's actually go ahead and write some code. So I'm going to go ahead and create our controllers folder. Let's first write up the to-dos controller. So each of our controllers is going to have its own router. So we're going to require the router module from the Express package. And then we can declare our router as a route. The advantage of doing that is that if we have any middleware for this specific controller, we can declare it inside this file. And then when we create our next controller, let's say the auth controller, any middleware for the auth controller will be inside that file. That way it's really localized. So for the to-dos controller, we're going to create only two routes. We're going to create a get route for listing all the to-dos, and we're going to create a post route for creating a new to-do. So let's go ahead and create the get route. You can say route.get, and then get request response. And then for now, we're just going to send a generic response saying that this is the get route for to-dos. I'm going to copy that and then paste it again, and then just change the get to post. And then finally, all we have to do is export out the route. So now let's go ahead and create our auth controller. So similarly, we're going to get the router package from Express. Then we can initialize the router. And then for the auth controller, we're going to have two routes as well. We're going to have a login route, and then we're going to have a register route. The register route is for creating new users, and login route is for existing users to log in. So let's create the register route. This will be a route.post because we're getting a new user. Then we get the request response, and then for now we're just going to say register. And then we'll create our login route, which will also be a post. Request response. And then finally, we're just going to export our route. Now in the server.js file, we can require both our routes. So we can require the auth controller and then we can require our to-dos controller. So now what we can do is underneath the Express application initialization, we can actually use both of those routes just like we would use a middleware. So we can say app.use and then / to-dos, and then we use our to-dos controller, and then app.use / auth, and then we use our auth controller. So what's interesting about this structure is that when the Express application receives a HTTP request with the to-dos flag, it will forward it to the to-dos controller. If it's a get request, the to-dos controller will send this response. If it's a post request, the to-dos controller will send this response. Similarly, if we have a / auth at the end of the route, the auth controller will receive it. If it's a register request, then it will be handled by this route, and a login request will be handled by this route. So we can go ahead and save the file and ensure that the routes are working. So let's pull up Postman again. So in Postman, let's test out the register route first. Remember, we have to say /auth / register. And then we also have to make sure that register is a post request. So, okay, that works. So we can say /auth / login. Login is also a post request. Cool, that works. Now let's test out the to-dos controllers. So we can say /todos, and we can leave it as a post. And then this is a post route for to-dos, and then we just change it to get, and then send the request again, and then we are the get route for to-dos. So everything works. So we've verified that our controllers are working correctly, but there's no meaningful functionality here. And in order for us to do that, we need to hook up a database. Let's talk about connecting our application to a database. There are three main ways we can connect our application to a database. We can download and set up our database locally. So if you wanted to set up MongoDB or MySQL or Postgres, then you download that respective database and then set it up locally. There are a couple of disadvantages with this approach because you have to download each and every database onto your computer, and then setting that up requires some process, which can be kind of difficult, and also varies from computer to computer depending on the operating system you're running. So it's different on a Mac versus Windows versus Linux. The second and more popular option that most people choose is using something called database as a service. Examples of this would be MongoDB Atlas or MLab, and for Postgres there's something called Elephant SQL. The advantage of this over the first option is that you can manage your database on the cloud, so you can set up accounts, you can delete and remove databases as you wish. So aside from the first two options, there's also a third option, which is running a database instance via Docker. For our tutorial, we're actually going to choose this last option. So what are the advantages and disadvantages of running a local instance of a database using Docker? So disadvantage number one would be downloading and installing Docker. Number two would be you have to understand how Docker works. But both of these are minor in my opinion. In fact, you don't have to understand how all of Docker works, you just have to know a few commands. And if you know these few commands, then there are so many upsides to this approach. You can run any database or service you want that's available on hub.docker.com and instantly run it in your computer at one command. This is so powerful. You don't have to worry about registering or setting up or deleting any of your accounts on MLab or MongoDB Atlas. And then you can also start and stop Docker containers easily. Moreover, you can run multiple containers at once. So we're going to be running MongoDB using Docker. There are literally two steps to do this. The first step is to download and install Docker Desktop. You can go to www.docker.com/product/Docker Desktop, or you can just Google download Docker and you'll go to this link. And they have a very straightforward process for installing it on either Mac or Windows or Linux. Once you've done that, you just open up a terminal and run this command. We're just going to say docker run -p 27017:27017 space Mongo. And that's it. You should have MongoDB up and running. Before we go ahead and run this command from the terminal window, let's actually understand what it does. So Docker just stands for the Docker CLI. It should have been automatically installed in your computer when you downloaded and installed Docker. The run command fetches an image from hub.docker.com and runs it automatically. The -p flag stands for port mapping. What does that mean? Docker containers are isolated by default. What that means is when you run a Docker container using the run command, then there is an image formed inside your computer that is completely isolated from the rest of your operating system. So in order to access that image, we have to use something called port mapping, where we map the port in your computer to a port in the Docker container. The first number before the colon stands for your computer's port. The second port stands for the port of the Docker container. Now, since we're using the MongoDB image, the default port for Mongo is going to be 27017, and this is the port that the Docker container that's running the Mongo instance is going to have. We're mapping that same port number in our computer to that Docker container. This number can actually be anything you want. It can be 5000, 4000, or any other available port. Finally, the last one is the image name. Mongo is the name of the official image on hub.docker.com, and that should be specified last. Now, there are a lot more options that you can give the Docker command, but we're not going to go into those. If you want to really understand how Docker works and understand the different commands and instructions that are available, then I suggest you take a tutorial on it. But for our purposes, this is more than enough. When you've downloaded Docker Desktop, you should see this small fish whale-like looking icon on the top of your screen if you're on Mac, or if you're on Windows, it should be on the bottom. When you click on it, you can open the dashboard. The Docker dashboard basically shows you all the containers that are running right now. I don't have any that are running. So I'm just going to open a empty terminal. I'm just going to do it inside VS Code. And here I'm going to run the command that we talked about earlier. Docker run -p 27017 Mongo. So this started up the Docker container. Now if you go to Docker desktop, you'll see that it has a container running. Now all that's left for us to do is to connect to this container using Mongoose. We've already installed Mongoose earlier, so we can just go ahead and directly require it in our server.js file. And then before we initialize the Express application, we're going to connect to MongoDB via Mongoose. So the mongoose.connect function takes two parameters. The first one is the Mongo URI, and the second one is the options. So the Mongo URI for our Docker container is going to be as follows. Our Docker container is actually running in an isolated container in the operating system, but the way we access it is through port 27017 in our local machine. So when we go to localhost :27017, our request will be forwarded to the Docker container because of the port mapping that we implemented earlier. Now the Mongo URI also takes the default database name at the end of the URI. We're just going to call this auth. So the options for Mongoose is an object that has several properties. For now, I'm just going to leave it empty. When we run the Mongoose connect command, it will actually give us several warnings, and we can include the options from those warnings. The mongoose.connect function is actually a promise, so we have to include a .then in case the connection is successful. And when the connection is successful, we're just going to console log successfully connected to the DB. If there's an error in the connection, then we're going to console.error connecting to the DB. Okay, now that we have everything set up, we can save it, and we see that NodeMon automatically restarted our app and we get an error. So like I mentioned before, the Mongoose ORM is automatically going to give us a warning. So it's asking me to include the use new URL parser property in the options object. So I'm going to just copy that and paste it here and then save. We're still getting an error here. That's because I made a mistake earlier in the Mongo URI. This should not be an HTTP request. It should be a MongoDB. So now when we fix that and save it again, we get successfully connected to the database. Okay, cool. So our database connection is actually successful. We can actually go ahead and see what our database looks like. When you click on that container, it shows you the detailed view. Here you have several options. When you click on the CLI option, it's actually going to open a shell. So in the shell, you just type in Mongo to enter the MongoDB shell. And then here, you should be able to type out this command, show DBs, and that'll give you the list of databases that are available currently. If you remember here in the URI, we mentioned the name of the default database as auth, and we can see here that it doesn't exist. That's because this database is only created when we insert a object into the collection. So we have our models defined, so we can go ahead and import them in our controllers and start adding functionality. Let's actually go ahead and import the to-do model in our to-dos controller. Require models to-do. Okay, now before we actually start writing code, let's actually understand how this request works. The GET request to the to-dos controller, when we receive that request, we're going to look in the database for all the to-dos, get all of the to-dos, and then pass it back. So here we need to get an array of to-dos. The post request, on the other hand, is going to give a new to-do to our controller. When we get that new to-do, we need to look for the to-do in the request body extract it from the request body, and then insert it into our database. So first, let's implement the GET request. So in order to find all the to-dos in our database, we can just say const to-dos, and then we can get our to-do model and then say find, and then this will by default return all the objects in the database that correspond to the to-do model. However, this is an asynchronous request, so you want to add the await keyword before it. Make sure you also have the async keyword in front of the function. After we've received the to-dos, we can just say response.send and then send the to-dos back. Let's check if that works. Make sure it's a GET request, hit send, and then we have a new to-do. Now you might have an empty array instead of this. That's because I already inserted one to-do when I was testing out the post request. Now let's go and implement the post request. So for the post request, we need to actually get the to-do from the body. So let's actually go ahead and type out the request first. So we're going to have a JSON object with a property called text, and then the value of the text will be the actual to-do. So we'll say buy milk from Walmart. That's our to-do. So when we send it, right now we just get post route for to-dos because we haven't implemented it. In our controller, however, we have to extract this from the request.body. So before we go ahead and insert it into our database, let's actually see what comes across in the request body. So here, I'm gonna keep the rest.send, but before I terminate the request with rest.send, I'm gonna console log request.body. Okay, so we can see what's coming through in the body here. So let me hit send, and ta-da, we get undefined. That's because right now our Express application doesn't know how to read whatever is in the request body, and in order for us to do that, we have to use a middleware called body parser. And if you remember, we actually installed body parser at the very beginning, so we just need to wire it up. And I know we said that we're gonna localize the middleware to each controller. However, this middleware is actually going to be used across both our controllers, so it makes more sense to initialize it in the server.js file as opposed to the todos.controller file. So here I'm going to initialize body parser. I'm going to say app.use body parser, and then I have to call the JSON function on it because the format of the data that we're sending over is JSON. So make sure you've required body parser on top. Okay, now when we send the request again, we see that our correct to-do is here. We see that it's being extracted properly. Cool. Now we can go back to our to-dos controller, and then we're going to destructure out the text from request.body, and then we can create a new to-do. Say new to-do, and then pass the text. This will create a new to-do, and then all we have to do is new to-do dot save. However, dot save is an asynchronous function, so you want to do await in front of it, and then what we will do is send the new to-do as a confirmation. Okay, let's check if that works. So it's a post request, so it's going to hit our post controller. I'm just going to send the request, and then we get buy milk from Walmart. Now let's actually go back to the get request and see if this has been added in our database. Cool, we see both the to-dos are here. Now we can actually open up our Docker dashboard, our Docker CLI that we opened up earlier. See here, we said show DBs, and it only showed 3 databases, and our auth database was not available. So here we can run that command again, show DBs, and we should see that the auth database is available here. Now in order for us to look inside the auth database, we need to say use auth. Okay, now we've switched to auth. Now we say DB. Okay, now we say show collections, to display the list of collections available, now we can say db.todos.find. Remember, the find function basically returns all the different objects in that collection. So we see there are 2 objects in the collection. We have new to do and buy milk from Walmart. Now that we have our to-dos controller set up, we can actually also set up the register route in our auth controller. So before we write code here, let's understand how the register route works. So I'm opening up Postman again, and here we go to auth/auth/register, and then this is going to be a post request. So I send it over. At this point it doesn't do anything because we haven't implemented any functionality, but we have to send over data in this request as well. We're going to send a JSON object with an email field. So let's just say test@nexttrack.io, and then we also have to send a password. So for this, we're just going to say password like that. And then when we send this, we actually expect the register route to extract the email and the password and then save it in the database. So let's actually go ahead and implement that. For this, we're going to need the user model. So const user equals require models, not controllers, /user. And then just like we did with the to-dos route, we can extract the email and the password from request.body, and then we can use this to create a new user, and then just pass it here. And then all we need to do is call new user.save. However, again, remember that new user.save is a async function, so we need to use the await keyword. Await, and then after we've successfully saved it, we're just going to return the new user object as a confirmation. Let's see if that works. Let's go to Postman, and then now send this request again. We get back the new user. Cool. So let's try something else. Let's try another user with a different email. Let's see. Demo. Whoops. At test.com. This guy will have a password of QWERTY. Okay, send it, and we get back the user here. Cool. Our register route is working in the auth controller. So now we can also verify that the user's relations have been updated in the database, the user's collection. So let's go to the Docker CLI, and then we can again say show collections. Now we have to-dos collections and users collections, whereas previously we only had to-dos. Now I can say db.users.find, and here we have 2 users that correspond to the 2 post requests that we made. So with that, let's end part 1 of this tutorial series. In part 2, we're going to talk about how we can store users in our database without saving their passwords as plain text. We need to use something called hashing. We're going to talk about encryption, hashing, and other terms, and go forward with our authentication series. See you in the next one.